Hello, my name is Anita Banser Ako, and I'm a data scientist. So my project name is Strava meets Zillow, and I thought about my project a few weeks into the data science course. I was on my way home after a long day in class, and it was about 7 p.m. It was dark outside, and I bumped into a runner, and it just got me thinking about, what is it about where I live that people feel safe running at 7 p.m. And if I look at trends in the data, is it possible to see an increase, to see that with an increase in workout, I could detect an increase in home prices or vice versa. So I decided to model the relationship between workouts and home prices. So that's how I came up with the idea of my project. So my data sources are twofold. There's Zillow and there's Strava. Zillow is a real estate website, and I'll be using it to get information about the median home prices in an area. And Strava is a fitness app, and it's used by people to keep track of their running and their biking. And Strava has these things called segments. What a segment is a section in a user's path that they can use to keep track of progress over time. So I'll use those to quantify the workout habits of a population. So the first challenge that I had when I worked with my project was the API for Strava gives you only the top 10 segments within a boundary that you feed it. So since I needed all of the segments, I had to split the boundary into tiny sections so I could get as many segments as possible. So I had to make sure that the sections weren't so small that they cut off the segments, but they were not so big that I missed a lot of segments. So with my first pass in Austin, I was able to get these segments. So if you look to the left, you see your biking segments, and if you look to the right, you see your running segments. And the biking segments are all over the place, and this makes sense if you think about it, because people don't necessarily bike where they live, but they run where they live. So when I found this out, I decided that I was not going to use the biking segments in my model. So my general workflow was this. I took the bounding box, which is the tiny box, and I feed it into the API. The API gives me the top 10 segments. And then I feed those into another API, which gives me information about the zip code and the metro. Then I save those to a database. And then I take the Zillow data and census data and save that to a database too. And I use that to create my models. So when I started the project, I was a little bit excited, and I collected data from 33 cities. But I soon found out that I wasn't able to use all of them because I didn't have enough data. And so this is a plot of Seattle, San Diego, Austin, Rochester, and New York. And as you can see, Seattle and Austin, the distribution of the segments per zip code are, spread out a little bit. But for San Diego, Rochester, and New York, most of the zip codes have only 1 or 2 segments, as you can see from the bottom white plots. So I ended up using data only from 4 places, which were Austin, Seattle, Charlotte, and Birmingham. So these are the plots that I got from plotting. On the x-axis, I have segments per zip code per capita, and on the y-axis, I have the median list prices per zip code. And as you can see, there is a relationship, a positive one, between the segments per zip code per capita and the median home prices. And their correlation score is about 0.7 for the 4 plots. Same with Charlotte and Birmingham. So I was able to prove that there is a positive relationship between the number of segments per zip code and the median home price. But what I was not able to prove was that knowing information about the number of the workout activity would give you insight into home prices. And I couldn't do that because I didn't have enough data. So for next steps, I hope to collect data from more apps, from different apps. And I will use information about the activity that I collect on a more granular level, and maybe get information or get features like the distance to segments or the number of runners per X miles, and see if I can use that in models to improve accuracy. So in conclusion, the general problem of predicting house prices is a difficult one. And I didn't expect going in that I was going to find the silver bullet or the secret sauce. Zillow had a Kaggle competition a couple of months ago that they gave $1 million to the person who was able to improve on their estimate score. So if I had this secret sauce, I wouldn't be here giving this presentation. I'll be somewhere on the beach with $1 million. But so I didn't expect to get that, but I thought about the problem in a different way, and I came up with something new and different. And so this is my information for anyone who has any more questions about the project, and thank you.